Okay, so this is section 10.2, which is the fundamental counting principle. And we're going to start off with just practicing some simple factorial calculations. So problem 7 is just 4 factorial using the definition of factorial. It's n times n minus 1 times n minus 2 times n minus 3 till you get to 1, and then you multiply it out and you get the result is 24. Okay, our next one is 10. So it's 16 factorial divided by 14 factorial. And you could multiply this whole thing out, but what we said is you can take a number and you can start writing out the factorial, and then you can just stop at whatever number you want to and then just write factorial. So 16 factorial is 16 times 15 times 14 factorial. And I stopped there so that I matched what was in the denominator. This is 1. It's a very big number in the numerator and the denominator, but it's the same number. So ultimately, we just have to multiply two numbers together. 16 times 15 is 240. And then we have 12, which is 6 factorial divided by 6 minus 3 quantity factorial. So when we have something in parentheses like this, we do the math first. 6 minus 3 leaves us with 3. So we get 3 factorial. It's not equal to 6 factorial minus 3 factorial. It's the quantity 6 minus 3, which is 3, and they do factorial. So now we need to simplify it. So again, I can start to write out factorial and just stop when I get to whatever the factorial is that's in the denominator. So instead of going 3 times 2 times 1, I just leave this 3 factorial. And this ratio is 1. So I just get 6 times 4, 6 times 5 times 4, which is 120. 30 times 4 is 120. Okay, so we're going to skip over the other ones using the calculator. And we're going to go on to 27. So what we have is a panel containing 3 on-off switches in a row. So let's just draw that. So we're going to use a box. Here's our box. And then we're going to have these on-off switches that are like this. And we got 3 of them. So there's 1, 2, 3 switches, and they can either be on or off. Let's just group those all together because we got that. Okay. Now, assuming no restrictions on individual switches, use the fundamental counting principle to find the total number of possible panel settings. So we've really got 3 steps. We've got pick the first one, pick the second one, pick the third one. Step 1. So what are the 2 options? Well, there's on and there's off. Just like head and tails. It's what we would say is binary. It's either one or the other. So the number of choices is 2. Then this next step, step 2, is to pick this one. Well, it doesn't matter what we chose in step 1, so that also has 2 choices, on or off. And then you have step number 3. Again, it's on off. So this is our multiple step process. This that be n sub 1 times n sub 2 times n sub 3, and so the total number of different possible switch combinations are 8. 2 times 2 times 2, which is 8. Okay. Let's go to the next problem. 31. Actually, let's actually 28 is the tree diagram, and it's really just the same as the like flipping heads and tails, because on off head tails is a binary kind of thing. Okay, so we're going to move on to problem 31. So it says, in the previous section shows that there are 36 possible outcomes when 2 fair dice are rolled. How many would there be if 3 fair dice were rolled? So previously we had, for all the 1 dice there were 6 choices. So n sub 1 was 6. The second dice there were also 6 choices. So that's n sub 2. So you take you multiply the 2 together and you find out that there are 36. Okay, so that's what we already know. If you have 3 dice, then we just add 1 additional term, and you get 6 cubed. 3 times 3 times 2, which is 216. So there'll be 216 different options. So it was what matters, the order doesn't matter in this case. Let's do 32. It's a new one. Counting 5-digit numbers. How many 5-digit numbers are there in our system of counting numbers? So here's the 5 numbers. And then we're going to write down what are the possibilities. Well, the first number can be any number between 1 and 9. It can't be a 0, because if it was a 0, then it wouldn't be a 5-digit number. So there are 9 possibilities. For the second number, it can be 0, and it can go through 9. So there are 10 possibilities for the second number. And the same is true for all the remaining numbers. So there are 10, 10, and 10. And so the number of possible 5-digit numbers is going to be the product of those 5 things, which ends up being 90,000. So there are 90,000 5-digit numbers. Okay, we're going to go to 36. So we have a club. In how many ways could they do each of the following? Line up all 5 members for a photograph. So we've actually done this problem before. Actually, I asked you to do 35, but I mean 36, but let's go ahead and do 35. So again, what you basically have is you have 5 positions to put the person. And so there's 2 ways of looking at this. Again, you can look at, these are places that people could go, or you look at here's a position, who can go into that position. So I'm going to do it the second way. So here's the first slot, and so when you choose somebody for the first slot, there are 5 people to choose from. The next step is to pick somebody for the second slot. Well, if you picked 1 person for the first slot, there are only 4 people left over for the second slot. And likewise, you follow through and you end up with this, which is 5 factorial. And so the answer is going to be 120. So 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120. Okay, so now 36, it says schedule 1 member to work in the office on each of 5 different days, assuming members may work more than 1 day. So again, we have 5 days. The key difference between this problem and the previous problem is that it says that people can work more than 1 day. So the first day I have 5 people to choose from. The second day, because I can schedule the same person that I scheduled the first day for the second day, then there's still 5 people left over. And the same applies for each one of the days in the week. So again, those are the different steps. Choose somebody for the Monday, choose somebody Tuesday, Wednesday, Thursday, Friday. But I allow duplication, and therefore I don't reduce the number, and it actually ends up being 5 to the 5th power, which is 3,125 arrangements of schedule. Of course, the person has to work all 5 days. I would not be too happy about that. But now, if you had it where a member could only work 1 day a week, then you'd be back to this arrangement. Because once you've chosen them for Monday, they couldn't work Tuesday. And once you've chosen somebody for Tuesday, then the first 2 people who've chosen can't work Wednesday, and so forth and so on. Okay, 36, 38. So 38. Select 2 members, one to open their next meeting and another to close it, given that Bill will not be present. So if Bill's not present, then we only have 4 people to start with. So instead of having 5 is our initial thing. So step 1 is to open, and the second, so this is to open the meeting, and 1 to close the meeting. So we have 4 people to choose one from to open the meeting, and it says select 2 members. So if we select 1 member, then that member is not available to be the second member. You can't have the first member be the second member. So you're going to reduce the number of people to choose to close the meeting down to 3, and that product is going to give you the total number of options. If Bill attended, then it would be 5 times 4. Okay, 44. The Gourmet du Coeur restaurant offers 5 choices in the soup and salad category, and 2 choices in the bread category, and 4 choices in the entree category. Find the number of dinners available in each case. So we've got 3 steps in this particular process. And actually we're doing 44, not 43. So 44 says only a salad and entree are to be included. So if we look at a soup and salad, but we can only do a salad, so we don't do the total number in the soup and salad category, we just do a salad. So step 1 is to choose a salad, and there are 3 available. So that's N sub 1 is 3. Step 2 is to pick an entree, and let's see how many entrees there are. 4 choices for entree. So our second step is to pick an entree, and so you multiply those 2 together. That's N sub 2, and so the total number is 12. And then 48 through 50. So this is you're picking courses in different categories. And so there are 2 classes you can take in economics, 3 classes in mathematics, 4 classes in education, and 5 classes in sociology. And so we're picking these for this Jessica person. And we have the restrictions that she's not eligible for free markets or for group dynamics. So if we chose, say, problem number 47 says that all classes are available. So you would choose 1 out of 2 for economics, you'd choose 1 out of 3 for mathematics, 1 out of 4 for education, 1 out of 5 for sociology. And so you just take 2 times 3 times 4 times 5 to get the total number of combinations of classes. But in this case, she's not eligible for free market, so the number of choices in economics is reduced to 1. And notice I'm not writing down what is offered, I'm just writing down the number that are offered. For mathematics, there are still 3 available. For education, we have 1 less. So we're going to reduce the number of choices down to 3. And then sociology is going to still be 5. So when she chooses in economics, she has 1 choice. When she chooses math, there are 3 choices. When she chooses education, there are 3. When she chooses sociology, there are 5. And you multiply those together and you get 45 different arrangements. And then we're going to move on to 40. No, that was 48, not 47. So 49. It says all sections of minorities in America and women in American culture are already filled. So we do the same thing. I'm just going to use a letter here for economics. So we have 2 from economics. We have 3 from mathematics. And minorities is sociology, and women in America is sociology. So as far as education, we have 4, and then for sociology, 2 are filled, so we only have 3. So again, you just multiply these together, and you'll get 72 arrangements of courses. And then 50 is she does not have the prerequisites for controlled markets, college algebra, or language supervision. So that means she can't take those classes, not because they're full, but because she doesn't have the prerequisites. So control markets wipes out one of the econ classes. College algebra wipes out one of the math classes. Language supervision removes one of the English classes, but all of her sociology classes are available. So again, we just take the choices and you end up with 30. So that's how those problems work. Okay, so that's it for this section.